Merry Christmas and welcome to my seminar today about LLaVA and LLaVA-Med. Two of visual language model. Very famous. LLaVA is famous for general tasks and LLaVA model. LLaVA-Med is a fine-tuned version for medical tasks and especially is often used for VQA tasks. Here is some stats about LLaVA-Med, which is about the MedVQA benchmark, which the topics we are researching is about. LLaVA-Med is top three in the top three in VQA rank. It's a really famous dataset in MedVQA, and it also the top ones in two others very famous dataset on MedVQA, which are past VQAs and Slack English. Here's uh, how the step how LLaVA model is trained and the architecture. Don't worry about it, and will we will go deeper in later of this seminar. And you can see here the pre-trains have two the LLaVA model. First, we go to the LLaVA models, and the LLaVA model is trained with two stages, and here is this architecture. Um, Here we can see it have a two stage to train the models, which is pre-trains for feature alignment and fine-tune end-to-end. So and the on the top side here is architecture of the model. So let's move to the architecture of the models. The architecture of the model includes some components, which is vision encoder, projector, and language model. Vision encoder receives image as input, and LLaVA use the clip visual encoder, uh, which is the vision encoder here is VT vision transformer large, and here is the checkpoint, and it's after uh, when part to the vision encoder, it will return a vector z, which represent some high level features of the image. Then it needs to go to a projection layer um, with parameter w, and it's convert to uh, HV vector, which represent for the which is projected to the space of text encoder. And the questions here is directly go uh, embedded to the hash queue, which is also the text embedding of the questions. Here you can see S go to the vector H here will be computed by W multiplied by ZV, and we have ZV from the vision encoder, and this is the function G of XV. And the model here's the the data, the XT. So now we know that LLaVA is a VQA EU for VQA task. So we need data to put in the model to train, right? So here's the input of the model, which include XQ and XV. Don't worry about um, how it have a T here, but at the first, let's understand that in the first step, it will research it will receive an XV, which is an image, and XQ, the first question, right? At the time step 1. question 1. And then the model receive it in the first round and try to generate the answer with this input. So it will try to produce HA1, which is the answer for questions 1. And if t greater than 1, which means the the questions now will be like XQ2, and the image also the same, and we do not put the image to the next round, and we just put the questions XQ2 and try to produce to generate the answer, the second answer. Here's how it works. So the things here is how we get this data set, right? You know, image captioning is really popular task and really easy for us to find the image captioning data set. But in terms of like image with the instructions following, for example, like we have image and we want to ask something about this image, not just captioning, ask something like uh, what um, the color of the ball in the image, something like that, or um, what will happen next, what is happening in the image, something like that. Some we do not have many data set like that, so the researchers in LLaVA project produce some tips to generate this dataset to trains. I don't have an image here, so I will illustrate that like the following. Sorry, like the following. We have the researcher in LLaVA project will use uh, we as mentioned about before that we have image captioning data set, and now we need to somehow generate an like multi-turn QA data set like that. So here we will use a caption as the input and use GPT-4, which accept only text to generate the multi-turn data for us. And for example, here is a bro, yeah, a player, and the caption is a footballer play is playing football in a white stadium. The inputs to GPT-4 to generate the multi-turn here will be the caption here. The text will be the caption, and something so sometimes it's also the bounding box. For example, if we have the bounding box of the ball and the footballer here, we also pass this to the for GPT-4 the bounding box. For example, here like we have x1 x2 e1 e2 and x 3 e3 and x4 e4 for the ball, and x1 e1 x1 x2 e1 e2 for the footballer here. So we will also put it here, and then we will ask ChatGPT GPT-4 to based on this caption and bounding box generate the multi-turn, which is the chat between user and assistant. To generate uh, the multi-turn conversation dataset for us, let me check in the slide. Um, I think I will have and more clearer example when go to the LLaVA-Med. Sorry about this, uh, but now at this time we know some component of LLaVA model and how they create a multi-turn data set to train the model. So how to train? Here's, like I said before, first we have system message and we have the human instruct, which is like questions here. In this example, it's just two turns, but actually it can vary, depends on the uh, detail of the caption. For example, if the caption in the original dataset is long, we can have many turns uh, to 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 can generate more longer conversation, right? And the only the the thing that used for the loss function and to calculate gradient and update parameter for LLaVA model is a green part here, because the H instruct and system message here in the dataset, and now we try to predict the answer, right, for each turn. So here is an example. The input is the image, and user will ask questions and LLaVA generate the answer. For um, for but for some talk related, for some question related to some reasoning thoughts, it will start a new conversation and clear the histories. For example, in this part, it will clear the possible, the above, and input the image and also question, and LLaVA need to generate the answer. The same thing happen in the right, in image in the right. Here's an example of something need to reasoning. So it's just one turn, and but it's also multi-turn, something like that. Sorry about my mistake. Actually, um, the the dataset here is not only about multi-turn. It's also about it. There are um, three type of datasets of data in this dataset. The first one is this. The second one is describe image in the detail, in detail, and the another type is reasoning. And with the two type of data, the the lava will just use is consider this type data like one turn conversation, except the type, this type will be con, considered a multi-turn conversation. So okay, it's in lava. Let's go to the LLaVA-Med. LLaVA-Med inherit whole architecture from lava model, but it and the idea to create the data sets and train is something, I think there's something similar to the lava model. And here's how lava model was trained. It trained on medical concept for alignment, because lava model is trained on general tasks, and and when working with medical uh, field, we need to fight to train this model again in the with the medical data to align the model to extract features more related to medical. And it is the first step for medical alignment. The second step is fine tune, and it's um, fine tune on medical instruction tuning. Train on medical instruction tuning task. It will be similar to the task I described here, and I will go to detail in the later of this seminar. Then finally, is after um, two state of training, LLaVA-Med will be um, will be fine-tuned in some downstream tasks like medical visual charts and medical VQA on the three datasets I mentioned in the earlier this seminar. The LLaVA-Med here is, you can see here, is quite similar to the LLaVA I mentioned before. The It also receive the question, the image, the stop token here. Actually, it's a something like that, and the assistant will try to generate the caption. Here's the the thing I mentioned here. It is part of the stage one of fine-tune LLaVA-Med in medical field, which just about reap with questions like this. Sorry about the organization of this slide, but the questions, the instruction will be something like that, and um, we just train LLaVA-Med to try to generate the caption, detailed caption for the original image. Hmm. Okay, let's go to the process of generate multi-turn data set like the original lava. Here you can see the prompt that passed to the GPT-4 to generate the dataset for us. You can see here we will pass this system prompt to the GPT-4 and generate the output like the hand side. You can see here. With this input, um, is what note here is the image is not used to generate this dataset. The only thing used is the caption, and instead of boarding box like the lava original lava, here is add to some text that in the docs or in the original dataset, or somehow that's mentioned about the image. For example, we have an image here, and here is the caption of the image, and here is some live text that mention or talk about this image that's somewhere, and the output of the model will be like that, and we have the questions here and the answer here, questions here and the answer here, and it's either multi-turn data set. And when we train the model, what we will pass to the LLaVA-Med is the questions, and we will train the model to generate the answer here. So it is the multi-turn dataset, and finally is when and here is some example of LLaVA-Med after training on multi-turn conversation datasets generated by GPT-4, and here's the output. Um, so I think so, and the final results is quite impressive when, as I mentioned at the early of the seminar, when it's way on top of two over three very popular dataset, which is PubMedCLIP and Slack English, and it also in the top 3 years of VQA Rust, and that's why we have the seminar today. I think that's it for my today's seminar. It's time for questions and answer. LLaVA-Med with GPT? Yeah, okay. Here. Any questions?
Yeah, can you talk more about the results, like the statistical result, um, when compared to other model in the domain of medical?
Just like caption here. I will exit this slide and show it in original paper. Um, okay, LLaVA-Med. Here. It outperform all the model here in VQA Slice also, and past VQA it also outperform other model. I think the most important thing that LLaVA-Med outperform other models is not because of the architecture, because it inherit 100% from original LLaVA, but I think the most important thing is the ways it the data it trains on, and the way the researcher is LLaVA-Med generate the dataset by GPT-4 and train the model on this data.
Mm, I still don't see where they compare lava with GPT, like what lie or
Oh,
You don't see the number.
uh, we don't have number here, but you know, GPT is not used to train, is not trained to do this VQA task. GPT in this paper is just used to generate the data based on the caption. It's not see the image, it does not see the caption and generate the multi-turn conversation datasets to train the LLaVA-Med. So GPT actually do not train to directly to do these tasks.
Okay, does the model support multilingual input?
Multilingual input? Yes, it's but I think it's the support Chinese because the the set is have two versions. One's in English and another one's in Chinese. And here you can see an example of input in Chinese, and it answers in English.
Okay, so I see that LLaVA-Med is a vision language model that fine-tuned on Lava for the medical domain.
Yeah.
So can you tell me more about the limitation of the model itself?
Thank you for your questions. Um, Actually, I don't find any like drawback of this model because you can see in terms of quality of output, because you can compare it to other models. You can see it's outperform in most of the datasets, and I think the only thing need to be considered to improve this model in the future, I think, is about the number of parameters, because many other model with uh, many smaller model with a smaller number of parameter can achieve nearly can reach nearly to the performance of LLaVA-Med. LLaVA-Med now, with my knowledge at this time, is about 7 billion parameter. But PubMedCLIP or BiomedCLIP, I know is much smaller, and I know another model which does about under 2 million, 200 million parameter, which is by Med GPT. It also have quite impressive result on the dataset, and I think the the like the most advantages of these models is parameter.
Yes, can you show us about um, all of the training data that LLaVA-Med
Yeah.
had already fine-tuned?
Yeah. It here is a fine tune for VQA task. It's a downstream task, and the LLaVA-Med is fine tuned on 3 datasets. Wait a minute. First, in the first part, it is fine-tuned. In the first part, here, it is fine-tuned with PMC 50M dataset, and is the researcher filter about 600k image and text pair, and it was trained to in LLaVA-Med was trained on this dataset to like feature alignment, like I mentioned before, for medical domain. Is the first stage, and the second stage here it was trained on two datasets. Which one is the first one is multi-turn conversation, like I mentioned in the slide, and the second one is a public dataset, which is the second one is on public dataset. Good a minute to I will find this information. Anyway, anyway, I forgot this because it does only train on the generated datasets and fine-tune on the on the downstream task here. I forgot it.
Okay, so like seeing the figure 3, I am really curious about how they decide. Like I'm curious about the reason behind the decision of training the stage 1 with only one epoch and stage 2 with 3 epochs. In the paper, do they provide any insight about how they choose the hyperparameters, sort of thing like that?
No. In the papers, I don't see any mention about this. But I think when we look at the sample here, we can find the answer. Because the first step is to align the feature to the medical domain, and the example here is 600k sample, and we just train really a big number, so it does trains on one epoch, and the status is about, as I said before, is the 3 epochs and it's less sample. It does about 60k samples, so it needs to train 3 epoch. And I think another reasons is the state one is just about feature alignment, and the state choose will like how to say I think it's like direct the model to the task that to receive questions and try to generate the answer when it is the objective of the model, like try to answer questions related to medical tasks, when step 1 is just about image captioning to and focus on medical domain. Do you satisfy with my answer?
Yes, I do.
Yeah.
Okay, I have a question. Can you hear me?
Yeah.
Yeah, I want to know more about how they merge the token. Like after we receive the information extracted by the vision vision transformer or some some vision model. How do we convert it into tokens, and how do people concat it to feed into to train the projection between that's one between information from image and information from what embedding.
Yeah, okay. The projection here is a trainable layer, and the parameter in the vision encoder is frozen. So the output of the projection will be the same dimension with the text encoder, and we will concat here. We will concat this image encoder, projection of image encoder and questions embedding here together. So simply is the projection layers is learnable and with the same dimension, the same output dimension with the text embedding layer. So it's easy to merge, and it will be learned during the training process to predict the image captioning here.
So the projection will turn the concatenated embedding into some kind of language embedding token.
Yeah, it's like a projection, like vision encoder will receive the image XV and somehow project it to some Z space. I think it's a Latin space, and now we have the hash space, which is the space of word space of language, and the projection here will in linear algebra, I think it's like a transform matrix to somehow convert this somehow project the z vector to the hash space here.
Yeah, and about stock token, explain more where the stock token is.
Sorry, can you repeat your question?
Yeah, I was talking about the stock token.
Stock token.
Yeah, to divide between the image and the language part.
Yeah.
Yeah, so where exactly is the stock token going to be at in?
Exactly, the stock token. Here is example of the where stock token here is, and stock token actually is the triple of this symbol. What do you mean? Does I answer your questions or not?
Continue.
Yeah, so the stock token here is, I think it is right now for the training data, right? This the second table is for the data to train for the model, right?
Yeah, data to train the model.
So I have a question. What is the minimum hardware requirement to run this model?
Oh,
Are they mentioned in the paper?
I think it's not a minimum, but I will find you here. Here's a model LLaVA model, and it use 8 GPU A100. Yeah. Here's E for lava, original lava, and here is some hyperparameter like it's trained on 3 epochs.
So when they use for inference, how the hardware is changed?
I do not have information about it. Let me find on LLaVA-Med if they mention. Here it turns iterate lava to LLaVA-Med in 15 hours. The hardware, where the hardware?
I think we can calculate based on its parameter.
Yeah. It's not mentioned here, but I think we can calculate on the parameter. For example, it have 7 billion parameter, and if we train or infer on FB 33, then we need 4 bit for param. So with 7 billion parameter, we have bit. So it's about, I think it's about bit. Pi. Here is pi. How to convert? Then somehow let's convert to megabyte or gigabyte. You can calculate the hardware, the space we need to run this model.
So LLaVA-Med is has totally 7 billion parameters, hasn't it?
Yeah. I see. Just because it inherited 100% from lava, so I think it have the same parameter with lava, original lava. There are several versions of lava model. Which have because the text and the language model in lava, lava is combined by vision model and language model, and the main amount of parameter of lava it come from language model, and lava is language model of lava is llama, and it has several versions like 7 billion, 30 billion, and 65 billion, something like that. So I think mostly it depends on the lava model, but I think the version of 7B lava, if we use 7B llama,
a language model of the LLaVA. So I think it's the total number parameter of LLaVA model is a little bit greater than 7 billion. Any questions? Any questions? Oh, okay. If there are no more questions, I think I will end the seminar today here. Thank you for joining my seminar and Merry Christmas.
Yes, you too.
Yeah.
Merry Christmas, everybody.